let's go through scenario 1 together to see how you set up a motion problem. We need our meaningful sketch, our motion graphs, and our motion model, which is a position equation for each object moving and a velocity equation for each object moving. All right, what do we got here? I've already read through it, but let's read it through it again. Initially at rest. Okay, so what I had noted in my first reading was that means both skiers, their initial velocity is going to be 0. And they begin to accelerate at the same time down a straight ski slope. Okay, everything in here is going to be 1D motion anyway, but so it's straight. Skier A accelerates at a constant rate of 1 meter per second, so that's going to be 1 meter per second squared. And skier B accelerates at 1 meter per second, 1.4, meters per second. So that's going to be 1.4 meters per second squared. Remember, meters per second squared is the same thing as meters per second. Okay, so that's going to pull that out. Now I'm going to make my meaningful sketch. You certainly don't have to have it at a slight angle. I'm going to just kind of, to help me visualize what's going on, you can make it perfectly flat. What I really care about is you need an, oh, that's pretty. All right, so there's my x-axis. And it's going to have units, and so basically this little parentheses m tells me that any number on the axis is going to be in meters. I need an origin. Okay, now I'm ready to start putting, okay, so I got A and B and I got them both together, so I'm going to put one on top of the other. So I'm going to put A on top and I'm going to put B right below. Okay, you don't need the boxes. I like boxes for some reason. Okay, so I've indicated the initial positions. Why did I put them at the origin? Why not? Okay, you didn't have to. You do not have to put objects at the origin, but there's no good reason not to, so I did. Now the next thing is I need to indicate their velocities. And I'm not, what I really want you to do is just to make it clear what the initial velocities are. So that means V sub 0 for A. We're going to get a little, I don't want to do subscripts on subscripts, so in fact, let me just do it different colors. I'm not expecting you to use different colors, but since I have it, everything about A is going to be in red. So here we go. Its initial velocity is 0. What is B's initial velocity? B's initial velocity is 0. I don't like it when they're right on top of each other, but this is what the problem is. Okay, so now the next thing is their acceleration. So let's go back to red. And what we have is, we have A, and I can put A sub A equals 1.0 meters per second squared, and the direction is that way. And for B, it's going to be, the acceleration of B is going to be, what is it, 1.4 meters per second squared, and it's going to be that way as well. All right, that's the meaningful sketch. I'm not, to be honest, I'm not super happy with how that looks, but it's adequate, right? It's a meaningful sketch. Why is it meaningful? Because every single thing I need to know about this motion is in my meaningful sketch, and that's what makes it meaningful, okay? I know their initial positions, I know their initial velocities, I know their accelerations, I have my axis properly labeled. It's meaningful. All right, motion graphs, because your motion graphs are going to be based on your meaningful sketch. Okay, let's do the X graph. So what we have is, let's do red for A. So we're going to have a parabola. That's what speeding up from rest looks like at the origin, as you know. And then B is going to be a steeper parabola. Okay, so there's their xt graph. What about their velocity versus time graph? Okay, this one's actually a little bit easier to draw because they're straight lines. A's is going to be like that. And B better be steeper because its acceleration is greater. Now, I'm not going to be picky about, okay, I made B, maybe I made B a little too steep, but I'm not going to be too picky about that. Okay. All right, now the motion equations. Okay, everything I need can be out of this, I'm trying to highlight that, this meaningful sketch, and also I can glance at my motion diagrams to make sure I've got the signs of my equations, the signs in my equations are correct. So let's do the motion model. This is going to be my template, meaning this is like my starting format, and I'm going to substitute in the key values. So let's do, I'm not going to do colors anymore. X sub A. Okay, first thing, they start at the origin, both. We leave that out. They don't have an initial velocity, so I leave out the second term. So we're left with the last term. Now, 1/2 AT squared. I'm not going to write 1/2 AT squared. I'm going to basically say, what is 1/2 of 1? So half of 1 is 0.5 meters per second squared times t squared. I go ahead and do the algebra, right? Now, if you were to leave this as if you were to write this as 1/2 times 1, is that wrong? Absolutely not. I'm just not going to do it, okay? And you should be prepared to recognize what the acceleration of an object is based on this coefficient in front of the t squared. More on that later. What about B? Oh, let's just go ahead and do their velocity equation for A. So V sub A, A's future velocity, is going to be equal to its acceleration times time plus initial velocity. Well, that's going to be 0, so it's just going to be, now this one, there is no 1/2 times A, it's just A, so it's 1.0 meters per second squared times t. Notice the t is not squared on the velocity equation, unlike it is for the position equation. For B, okay, kind of the same thing. Its initial position is 0, leave that out. Its initial velocity is 0, so we leave that term out. So we just have 1/2 times acceleration times t squared. Well, what's 1/2 of 1.4? That's going to be 0.7 meters per second squared times t squared. Don't leave out the squared on the t over here. And the velocity equation for B is going to be, we don't do the 1/2 anymore. It's a different equation, different meaning. 1.4 meters per second squared times t. Again, don't square this t. This is a linear relationship. So velocity is a linear relationship. Position is a quadratic relationship. And that is it for problem number 1. Again, I'm not real happy with how I laid that out, but the key thing is, for this guy, I'll just draw this. The key thing for this is I have all the information I need. I know the direction of the acceleration from the arrows. I know the magnitudes from the values. I know their initial starting position, etc.